Dear students, good morning, namaste. Successfully we completed the straight lines, that is exercise 10.1, 2, 3, everything is over. Some examples also we solved. I want to tell one more thing. In this online classes, for some students, they are calling me and asking me that the sound system is not good, sir. The words what we are writing on the letters, words what I am writing on the board are not clear, sir, like that. It is the mistake, it is a technical mistake only. And here I want to tell one thing, you don't need to take worry. Again, after this problem is solved, not this problem. Problem is solved means the COVID problem is solved, no doubt it will be reduced in the month of June. We will take some classes and clearly I will tell it. Okay, na? Not only me, all the lectures will tell. You no need to worry. Okay, na? But for the purpose now, you have to try to take it. Okay, na? That is thing. So, straight lines is over. Exercise 10.1, 2 and 3 is over. Okay, na? Some theorems are also is there. In online classes, I got one theorem, that is the distance between parallel lines. It is very important. Okay, na? C1 minus C2 by root of 1 plus m square, where y is equal to mx plus C1, y is equal to mx plus C2. Okay, na? That is the thing. And if the lines are generally given, ax plus by plus c1, ax plus by plus c2, like that, then also c1 minus c2 by root of a square plus b square. That theorem is important. Okay? Yeah. That is over. Now, we want to take the exercise sequences and series. It is also an important chapter. Okay? In this chapter, some theorems are deleted. I will tell again. Now, in this chapter, this is a sequences. Okay, now we will start. You see, first you see the definition. Okay, now you try to take it down. Definition: the sequence. The chapter name is sequences, and the definition of sequences. You see, a sequence is a set of numbers arranged in a definite order. That means the sequence. What is the sequence means? It is set of numbers, a group of numbers. Okay, na? That numbers follows with one rule. A definite rule is there. You see clearly. A sequence is a set of. It is a set of points. You see, set of points. This is important. A set of numbers, not points, numbers, which are arranged with a definite order, so that all the numbers after the first number is without any definition, without any rule. You can start with any number. After the first number, all the numbers will maintain a definite rule. This is rule, a definite rule. Here the numbers are called as elements. They are called as elements. Okay? For example, 1, 3, 5, 7, dash, dash, or the set of odd numbers. Because here all the numbers are odd numbers. They are set of odd numbers. Okay, na? And is written by, this set is written by 2n minus 1. Very simply. 2n minus 1 where n belongs to capital N. Capital N means it is natural numbers. Natural numbers. Okay, na? That means put n is equal to 1. 2 into 1 minus 1, 1. When n is equal to 2, 2 into 2, 4 minus 1, 3. When n is equal to 3, 2 into 3, 6 minus 1 is 5. Like that, we will get the set of numbers. But here we have to put the commas, first number, second number, first element, second element, like that. Okay now, these are the set of odd numbers. This one is a sequence. Why? Because here you see each pair of each successive numbers, successive pairs, you see 1, 3 or 3, 5 or 5, 7 are related with some difference. 2 na, here also 3, 5, 2 na, here also 5, 7, 2 na, like that. So the set of odd numbers is called a sequence. Why? Because I will tell you. Another example, one more example. 2, 4, 6, 8. They are all a set of even numbers. Even numbers are? Yeah. They are even numbers. You see, you try to understand it. It is even numbers. And is written by 2n, where n belongs to capital, same. n is a natural numbers. 2 into 1 is 2. 2 into 2 is 4. 2 into 3 is 6. 2 into, like that, 4 is 8. Like that, the set of numbers will be formed. It also a fixed definite rule is there. To get a very successive number, to get to a very successive number, we have to follow a fixed rule. A definite rule is there. Okay na? In order to arrange those numbers. Okay na? That is it. In above sequences, you see all the numbers are arranged with one definite. It is one definite rule. That is the difference of every pair of sequence successive numbers. Every pair of successive numbers is the same. Here is a difference is there, 2, 2, 2. Here also 2, 2, 2. Or multiply with a number 2, 2. 2 into 2, 4. Like that also is there. Okay, Nana? Here is difference is 2. Here also difference is 2. Okay, na? So this is this set of numbers are arranged with a definite rule is there. So that it is called as okay na? Hence they are called as a sequence. Okay na? And one more thing, the general form of sequence is A1, A2, A3, A4, dash, AN. Okay na? They are called as a sequence. Okay na? A1 first number. General. Some condition maybe is there. Difference may be 2 or 3 or 5 or multiplying with or dividing with something is there. A1, A2, A3, A4. Every pair of successive terms having the same condition. That is important. Okay, like this. If the pair of every successive terms is following with a condition, generally I am writing A1, A2, A3, A4, dash, up to AN is the general form of a sequence. Here first term is, you see, where, okay na, A1 is a first term, whereas AN is a nth term. Okay na, this is T1, this is a Tn. Like that also we can mention. Okay na, you follow it well. Okay na, just, okay na, pass. Okay, so we learnt, we can understand that what is a sequence. Now we will go to series. Series means, you see that. I will tell first. There is a difference between a sequence and a series. the series can be obtained from the sequence if all the elements, all the numbers of the sequence can be signed, SIGN, can be signed with plus or minus or both. Do you understand it well? Okay, now you see, series means if all the elements, it is called as a element also. It is called as a element. Element means numbers of, just wait. All the numbers, I will write it as a numbers. All the numbers of sequences. I will write in it's not clear then, just if all the numbers, it is called as elements of any sequence can be signed, SIGN, it is signed with positive or negative or both, then it is called a series. Okay, na? In a moment. For example, you see A1 comma, I will write it in numbers. 1 comma 3 comma 5 comma 7 comma 9 comma or dash dash is a sequence. We know it well. The first example, a sequence. This is a sequence. It's not doubt. It is a sequence because every pair of successive two terms are with one condition. So here is the difference 2, here is also difference 2, 2, 2, like that. Okay, now first term is anyone, maybe, like that. So this is a sequence. If it is signed, you see, if 1 plus 3 plus 5 plus 7 plus 9 plus dash dash is, okay, now, is called a series. It is called a series because here the numbers are signed with positive, that is a plus. One more example. 1 comma 2 comma 4 comma 8 comma 16 comma dash dash is also is a series, is a sequence. Okay, now the sequence. It is a different one, not even numbers. Second example there, I gave the even numbers. But here 1 with the multiplication 2, again with the multiplication 4, again with the multiplication 2, 8. Okay, now 1 into 2, 2. First number is 1. If we multiply with 2, we get the second number. If we multiply with 2, we get the third number. Multiply with 2, 8. With 2, again 16. It's going on. It is a sequence because by definition, each pair of, here a ratio is there, not a difference. A ratio. If you take difference, here is only 1. Here is 2. Here is 4. Here is 8, like that. Not that one. It is not common. If you multiply, that means here the ratio for every pair of two numbers, every pair of successive two numbers. 2 by 1 is 2, 4 by 2 is 2, 8 by 4 is 2, 16 by 8 is again 2, So here all the numbers of the sequence are maintained by a perfect rule, a definite rule. So okay now, like that. So it is also a sequence. Don't confuse. Here it is difference. Here it is ratio. Okay now? If it is 1 plus 2 plus 4 plus 8 plus 16 plus dash dash is called series. Okay na? The difference is there. We can understand the difference. If it is a plus or minus also is also called series. Okay na? Understood na? Or otherwise you should or you see 1 plus or minus 2 plus or minus 4 plus or minus 8 plus or minus 16 plus or minus dash dash is also called a series. Okay na? So what is the difference between series and sequence means? If with commas, very simple, it is a sequence. With plus or minus or both is series. But all the elements, all the numbers are maintained by with one common definite rule. Here is the difference is same, here is the ratio is same, like that. Not only ratio, so many other relations are there. You see, what are the signs? Means plus, minus, into, division, square is there. Okay, now like that, many. Root is there, cube is there, square plus 1 is there, square plus 2 is there, like that. So many series are there. Later we will discuss. Very simply you take, what is the sequence? What is the series? The difference is only plus or minus or both. If you connect, all the numbers are connected. Here also we can say, you see, all the numbers of any sequence can be connected. You may write it as a sign or connected also. Connected. We may write it as connected also. With sign plus, minus or both. Then it is called as a series. Okay na? It's clear? Yeah. Yes. Okay Nana? Now we learned about sequences and series. We know the difference between sequence and series. Now, you see, and notice that finite, F-I-N-I-T, finite and infinite sequences. Okay now? Or series also. Finite, infinite. Okay na? Sequences are series. Series can be obtained from sequences, we know it well. If put the commas in if you connect all the elements with the commas, it is sequence. If it is connected with plus or minus or both, is series. We know it well. Now you see, what is finite? You see, if the number of all elements of a sequence or series is a finite or infinite, then they are called finite sequence or series and or otherwise infinite sequence. In the bracket you write it a series. Here also you write in the series. So sequence or a series. If it is when we call the finite sequence, the given set of numbers with one definite rule is called a finite series. Means the number of, here the number of all the elements, or if it is finite. If it is finite, it is called a finite series. If it is infinite series, infinite number of elements are there, it is called as a infinite series. Okay now? See, with one example we can understand. Say with example. 1 plus 3 plus 5 plus 7 plus dash 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 plus infinity. Okay now? Is called infinite sequence. Okay? Here it is not sequence because I mentioned with the plus. So it is infinite series. Suppose it is 1, 3, 5, 7, dash 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 up to infinity is called infinite sequence. Okay, you understand it? Yeah. For example, another one. 1, 1 by 2, 1 by 4, 1 by 8, 1 by 16, and so on up to 1 by 2 power n. Okay, na? It's a different one. I am giving a different. You see, here 1 by 2. The pair of first successive terms, 2 terms, a pair of 2 terms. 1 by 2. The first number is divided by 2. And again the second number is divided by 2. 1 by 2 by 2, 1 by 4. 1 by 4 by 2 is 1 by 8. 1 by 8 by 2 is 1 by 16. Okay, na? It is 2 power 1, 2 square, 2 cube, 2 power 4, dash dash, 2 power n. Here it is not infinite. Infinite is not there. So it is called is called a finite. It is a finite sequence. Okay, na? Because here is the commas are there. Don't confuse. Commas are there, sequence. Plus is there, series. Very simply take it. But if you see here the number, there are n plus 1 numbers are there. A finite number of all the set of numbers, the number of all the elements, the number of all the total number of all the elements of the sequence is finite. So it is called as a finite series. Whereas here the number of, if the all the number, the total number of all the elements of the series or of the sequence are infinite, many number. Unlimited numbers are there, unlimited elements are there. So it is called as a infinite. Try to understand it. Okay, na? Here is infinite number of numbers are there, infinite number of elements are there. Of course, they are connected with one definite rule, that is leave out. That is the first one. We know it well. It is with commas or plus, okay, commas, sequence plus series, okay. Here our problem is, our concept is whether it is finite or not. Here the total number of elements are infinite, so it is infinite series or infinite sequence. Here it is a finite number of, the total number of elements are finite. How many numbers are there? Here n plus 1 numbers are there, don't confuse it. 2 power 1. Second number is 2 power 1, 2 square, 2 cube, 2 power 4, 2 power n. So up to this one, you see my finger. Up to this one only n terms. So one more. So here n plus 1 terms, a finite number of elements are there in this sequence. So it is infinite. Also we can write it as 1 plus 1 by 2 plus 1 by 4 plus I will write it as. Here it is 1 by 2 square, 1 by 2 cube, 1 by 2 power 4, dash dash, 1 by 2 power n is called infinite. Here also it is a finite series. It is a finite series. Okay? So we can understand what is a series, what is a sequence. What is the difference between finite series and infinite series? Okay? Is it clear? You go through it. Okay? At 1 mark or 2 mark, a question will be asked. What is infinite series? What is the difference between series and sequence? Like that we will be asked. Okay? Please. Okay, we'll do some examples. Example 1. Write down first 3 terms or numbers of a series of a series where an is equal to 2n plus 5. You say, when asked to find the first 3 terms. Okay, na? Here series is simply a series. What is the series? Where an is equal to 2n plus 5. You see, an is equal to 2n plus 5, where n belongs to capital. Here also, n belongs to capital N is there. A series, simply it is a series. The series is this one. This is the series. It is a series. That means only nth term is given. If n is equal to 1, 2, 3, 4, 5, dash dash up to n. What is a1 first number? 1 is equal to 1, a1. It is 2 into 1 plus 5. It is 7. a2 2 into 2 plus 5. 9. a3 2 into 3 plus 5. How much? 6. 11. And it is going on up to an. That is 2n plus 5. Okay, na? It is 2n plus 5. That is a series. It is also a series. It is also a series. Not this one. This one. Now, required series is, first one is 7, first term, a1. Next 9, 11. Next, okay, na? Here also odd number is there. 7, 9, 11, 13, 15, and the last one is 2n plus 5. Okay, na? Here. The first 3 numbers or terms, we may call it as terms. The first 3 terms are 7, 9, 11. That is the question. Okay, na? Is it clear? Like that we write. One question. Here this series is finita or infinita. finite series or infinite series. It is infinite series. Why? Because I will tell it. Infinite series. Because here n belongs to capital N. Capital N means it is going on up to infinity. N is equal to 1, n is equal to 2, n is equal to 3, n is equal to 4, n is equal to 10, n is equal to 100, n is equal to 1 lakh. It is going on. So wherever like this is there, of course it is nth term. It is not putting infinity. But we can substituting by successively by using n is equal to capital N natural number. We will get up to so it is infinite series. The first 3 terms is only 7, 9 and 11. Okay, na? Is it clear? Yeah. Next we will go to the first exercise. Okay, Nana? Yeah. Thank you.